Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 7 of JEE Advanced Physics paper 2017. Hello students, let us solve the next question. The question is for an isosceles prism of angle A. There is a prism. Both sides, two sides are same. Isosceles prism of angle A. This angle is A. The refractive index is mu. It is found that the angle of minimum deviation delta m is A. So for the angle of minimum deviation, we know that the ray has to be parallel to the base. This is how the ray goes, and this is the normal to this face, and this is the normal to this face, and this angle is I1, this angle is R1, this is R2, and this is your E. This is how and is given that what is given, delta m, that is angle of minimum deviation, is equal to the angle of the prism. Now which of the following options is or are correct? So we have to check all the options. For the angle of incidence I1 is A, so for option number 1, I1 becoming A. For I1 equals to A, if this angle of incidence is equal to this one, and in that case the ray inside the prism is parallel to the base of the prism. So we know that I1 is A equals to delta m given in the question. So obviously the ray undergoes minimum deviation so the ray inside the prism is parallel to the base of the prism. So this one is correct, because whenever the ray is undergoing minimum deviation, then it becomes parallel, and as it is shown that the I1 equals to A, but then A is delta m, that is known to us. So if I1 is A, if angle of incidence is equal to angle of prism, that we know that it always undergoes minimum deviation, so that will be parallel. That is okay. That is theoretical question. What about the next one, that for this prism the refractive index mu of and the angle A are related to this and this. So for that, let us first find okay, for option number 2 I'll write that mu, the prism formula. The prism formula for the prism is mu equals to sine of A plus delta m divided by 2 divided by sine of A by 2. This is the prism formula, and therefore this mu is sine of A plus delta m is given as A, because this is given as delta m is A, so it will become A by 2 divided by sine of a divided by 2. This is 2a by 2, this is a, so this becomes sine a divided by sine of a by 2. This sine a can be written as 2 sine of a by 2 into cos of a by 2, because sine 2 theta is 2 sine theta cos theta, so I can write this sine a as 2 times a by 2, that is theta is a by 2, so it will become 2 sine a by 2 and cos a by 2. This is equals to and divided by sine a by 2. So from here this will cancel out. So this will cancel out and we have mu equals to 2 cos of a divided by 2. So from here I can write that cos a by 2 is mu by 2, cos of a by 2 is mu by 2, or a by 2 is cos inverse mu by 2. So from here a equals to 2 cos inverse mu by 2. So this is the expression we are getting, and the question is given that a and mu are related like this. A is half of cos inverse mu by 2, but here we are getting 2 times cos inverse mu by 2. So this option is not correct. This should be 2, it's not half. So this option is wrong. Now let us see the option number 3 that will check. It says that at minimum deviation, the angle of incidence I1 and the refracting angle R1 at the first refracting surface are R1 is, this is 1 actually, this is R1, R1 is I1 by 2. So what is the question? The question is that if at minimum angle of deviation, so this is the angle of deviation, minimum angle of deviation. If this angle of deviation is minimum, then at this first refracting surface, this is I1 and this is R1. It says I1 and R1 are the first refracting surface. They are related like that. So first we have to relate whether they are related to this like that or not. So this is the option number 3. I1 R1 first refracting surface, angle of minimum deviation is delta m. In that case, how this R1 and I1 related, that is our question. We know that I plus E is A plus delta. This is general formula. So when this delta becomes minimum, that means delta M, and this becoming A, then these two are equal. So I can write these two are 2 of I. In this case it is I1. But also we have at the same time when delta becomes minimum, we have R1 plus R2 is A. This is how these two refracting angle is related to the prism angle A. So R1 plus R2 is A, but at minimum deviation this R1 and R2 are same. These are equal, just like these are equal. They are equal. R2 is replaced by R1, so 2R1 is A. If 2R1 is A, then R1 is A by 2. So from here I am getting R1 is A by 2. R1 is A by 2. And from here 2I1 is A plus delta M. 2I1 is A plus delta M. But delta M is equal to A. that is given in the question. But already we know that this delta m equals to a, and therefore I'll put a here. So this will become a plus a, that is 2a. So 2i1 is 2a, 2i1 is 2a, so i1 is a. This value I substitute here, so I'll get r1 is a by 2, which is in fact i1 by 2. So this is how they are related. R1 is I1 by 2, so this option is correct. R1 is I1 by 2. As far as the fourth option is concerned, let us see what is the value of that. So as far as this fourth option is concerned, this question says that for this prism, the emergent ray at second surface will be tangential. This ray will be tangential, means it will move like this, in this direction. This is for option number 4. For this ray to move along the surface of the second surface, when the angle of incidence at the first surface, at this surface, is this. So if I1 becoming this value, then only this will graze the surface. Okay, this is the question. So for that, what we will do, we will use the concept that for that to take place, what we'll do is at the first phase, that means if I apply Snell's law to the first surface here, this is the ray and this is the ray, goes like that. This is my I1 and this is my R1, and this side when this surface is there, this is my R2 and this should be the ray, so this angle is 90, this angle should be 90, and that is equal to E. So for this I have E equals to 90 for the ray to graze the surface, so this angle should be critical angle, then R2 should be critical angle, because when the ray is incident or moving from denser medium and it is incident at the rarer medium at an angle of incidence equal to the critical angle, then the ray becomes parallel and the refracting angle at that time is 90 degree. So R2 is theta c, but we have the relation, because I want to relate this with this, so I have the relation between these two angles, and that two angles are related as R1 plus R2 equals to A. So I'll write, I don't want R2 because R2 is obviously theta c, so R1 plus theta c should be A, and I want R1, so R1 can be A minus theta c. You can write like that. If I apply Snell's law here, so I can write mu of this, mu sin I equals to mu, sorry, sin I, this is 1, so 1 sin I is mu sin of R1. I'm applying the Snell's law to this surface. The ray is moving from air, so n equals to 1 to n, or refractive index equals to mu. So I'll write 1 into sine of this angle. This is 1 into sine of this angle is mu of sine of this angle. So that is sine I1 is mu sine R1. So I'll write sine of I1 at the first surface is mu times sine of R1. Okay, but then R1 I got, R1 I want to write in terms of the other angles. So this equation I can write mu sine of A minus theta c. That way I would write. So then this sine A minus B formula to apply. Sine A minus B is sine A cos B minus cos A and sine of B. This is the formula to apply. So if I solve this, then this becomes mu, and for this second surface, this is normal. The ray was going like that. This was the incident angle, and this is the surface. This is becoming 90, and this angle is a critical angle. And for these two, I have the relation that the sine of theta c equals to 1 over mu. This is the relation, and this relation can be used that in place of sine theta c, I can write 1 by mu. But what about cos theta c? Because cos theta c is 1 minus sine square theta c, the root. So in place of sine A, I will write only sine A. Cos theta c is this. So 1 minus sine theta c, sine square theta c under root, minus of cos of A, and sine theta c is 1 by mu. Sine theta is 1 by mu. And again, I will write sine theta c as 1 by mu here. So this equation becomes mu sine of A under root of 1 minus sine theta c 1 by mu. So sine square theta c becomes 1 by mu square, minus of cos A divided by mu. If I solve this, then this becomes mu square minus 1 divided by mu square root. This mu comes out of the root and it becomes mu. 1 mu here, 1 mu there, 1 mu there, then it cancel out. Mu into 1 by mu cancels out. And this inside it is sine A mu square minus 1 root minus cos of A. Okay, so this is what you are getting. Now sine I1, finally we are getting sine of I1 equals to sine of A under root of mu square minus 1 minus cos of A. If I see the option, it says that the I1 should be sine inverse of this value. So I have to write, simplify this further in terms of cos, this is A by 2 actually, this is A by 2, that I have to write this expression, I have to find this expression, and I1 is sine inverse, so from here I1 is sine inverse of sine of A is there already, root of mu square minus 1 minus of cos A. What is given in the question is that this I1 is this. What is that I1? I1 is given as sine inverse sine of A under root of 4 cos square A by 2, 4 cos square A by 2 minus 1 the root, and minus cos A, minus cos of A. If I compare these two, then if I can write this expression in terms of this expression, that means mu square I can write, if I write as this, then it is correct. So let us then find whether this mu square is equal to this or not. If mu square is this, then this, that option is also correct. So we know that mu equals to 1 over sine theta c, because sine theta is 1 over mu, so we can write like that. And theta c is in terms of, so we have mu equals to 1 upon sine theta c, and this can be just used, this expression can be used from the expression that we obtained in the previous option number 2. In option number 2 we got mu equals to this one, so squaring this will become 4 cos square a by 2. So substituting that, we'll have this value. So this option is also correct. This is directly obtained from, because mu equals to 2 cos a by 2, so mu square is 4 cos square a by 2. That value directly substitute there and you will get the options. So for this question number 7, option 4 is also correct. So 1, 3 and 4 are correct. 1, 3 and 4 are correct options for these questions. Okay, thank you.